Hey, what's up, guys? Welcome to my lecture series of algebraic geometry. And today I want to prove another important fact that basically the induced map on the spectrum is continuous and the contravariant functor. So this one is also important property that also showing the vakil access to a three of vakil exercise. So as I say that algebraic geometry is difficult. So if you don't do some exercise, or at least some important properties are inside the exercise. So if you don't do this calculation by yourself, then you are not doing anything. Okay, so I mean, I did. So all these are difficult, but okay, so but I still understand it, and I try to make a video. So hope you guys subscribe to my channel. Okay, so as we said before that let me just quickly review. So it's a commutative ring with identity. And you can associate with spec A, which is a prime ideal of A. So you collect all the prime ideal of A and call the spectrum. And yeah, and then you can and you can define a V of S, which is a text subset of a ring, and which collect all the prime ideal which contain S. Okay, and the V of S, and then you define V of S to be closed. Okay, now this will give you so-called Zariski topology. Okay, so this will make the spectrum of A as a topological space. Okay, so what I want to the important fact is that so immediately have a question is that if you have a ring homomorphism from A to B, then what would you get? Okay, so obviously the theorem is very simple. If you start from a ring homomorphism from A to B, then you can define a you can define a map which from spec B to spec A. Okay, so it's very simple. You just define a phi of star P. Let's say you start from some spec prime ideal of B and define to be phi inverse of P. Okay, so this tells you that there's a theorem which tell you that if P is a prime ideal of B, then phi inverse of P is a prime ideal, is an ideal of A. Okay, so the proof is very simple. So you can check it's a prime ideal, but basically you can take, as you take x, y, b belongs to phi inverse b. So this will give you x, phi of x, y belongs to p. This will give you phi of x, phi of y belongs to p. And then this will give you that either phi of x, since prime p is a prime ideal, so phi of x belongs to p, or phi of y belongs to p, and then this will give you x belongs to phi of inverse p, or y belongs to phi of inverse p. Okay, so if P is a prime ideal of B, then its inverse is an prime ideal of A. Okay, but this only proves that this map is well defined. Okay, so obviously that this map looks as a functor, right? Because it has some basic, it just comes from a function. Okay, so obviously that if you start from this right now, so if you start from A to A, which is identity, then you can also take this, right? So this identity map will give you identity map on spec A. Okay, now obviously that if you have, let's say, A from B is B, and F is from A to B ring homomorphism, and B to C ring homomorphism G, and so you can create F star. Let's say I call it F star, which is from spec B to spec A. And then you can also define G star from spec C to spec B. Okay, so obviously that you will have the following. You will have the G circle F, take the star, will give you F star G star. Okay, and this proof is very simple. They just, by definition, it just G inverse P, F inverse P will be GF inverse P. Okay, so this this already give you the results. That this induced map is a contravariance functor, right? By definition. Okay. So now vakil also has an exercise that we want to prove the following is that we have ring homomorphism from A to B, right? So we have phi star, which is defined to be spec B into spec A. So previously this map just as a topological, as a set, as a map from set. But since we add the Zariski topology on it, so we want to say that phi star is continuous. Okay, so claim phi star is continuous. Respect to Zariski topology. Okay, so this is like a hardcore not difficult, but you just write down every detail. So in order to prove it's Zariski topology, we want to prove that if P, we want to take the closed set and go back to and prove that it's closed. Right. So the key point is that let's say we take ideal. Let's take ideal of A. Take ideal of A. Okay. Okay. Then what we want to prove that we want to show that it's closed, right? So we want to prove that this map is closed. So I take this A. I take ideal of A, and the closed set of spec A in the spec A is V of A. Right, so let's say VA. Let me just write VA to be the vanishing set. So recall that VA is a prime ideal in spec A, such that P contains A. Okay, so let's write down a proof. So we want to prove that we want to prove that phi star inverse V of A is closed. Okay, so let's take the element belongs to this guy, right? Because this is the inverse of this phi star map. Okay, so but this phi star is just phi inverse, right? Okay, so this tells you that Q belongs to phi of VAA. Okay. Right. So because phi inverse. Okay. Okay. So since Q belongs to phi AA, so this tells you that phi inverse Q belongs to VAA. Okay. Then the VAA is VAA in element between VAA will contains A, right? So this is if only if phi inverse Q will contains A. Okay. But this tells you that phi of A contains Q. Okay, so this tells you that Q contains phi of A, right? So which means that Q belongs to vanishing set of B contains phi of A. Okay, and you can check that all these actually that all these are if and only if. Right? So finally you can prove that Q is a if and only if VB phi of A. Okay, so this tells you that phi star inverse B of A is just VB phi of A. Okay, so it's a van, so this guy is closed, right? By definition. So which proves that this phi star map from spec to spec A is basically the continuous. Okay, so our final result is that phi from A to B, right, will introduce a continuous map from spec B to spec A. So this tells you that the spectrum as a map is a contravariant functor from continuous function for a ring to the topological space. And this is contravariant functor. Other than I think all the proofs are provided in this video, and I hope you guys subscribe to my channel.